what I thought we'd do for the first part of class today is just kind of leave open time for everyone to ask questions and get any help needed to get set up on GitHub or Collaboratory, or you could ask questions about any of the module 3 material or the assignment 3. And then we can take as long as people want with that. And then I also have some like kind of other Python stuff that I can show you if there's time for that, but we don't have to. So does anyone have any questions or stuff you'd like to bring up? Yeah, Emily.
I'm just like, I watched the videos explaining GitHub, like the introductory ones, but I'm not totally sure like what it's used for and like in the context of this class, because I've taken a few classes before that use like Python and Colab, but we never used GitHub. So I wasn't sure like how it fits in and like what you'd be using it for, because I was having some trouble downloading it too. So I'm not really sure like if I'm doing it right.
Sure. So, well, there are a few things there. So first of all, we're going to use GitHub for like code management and sharing data stories, and also for submitting assignment 3. You don't need to download anything on your computer to do assignment 3 or to submit assignment 3. You can like connect Google Collaboratory directly to GitHub. I can show you how to do that. But yeah,
like all those like things it was talking about, like and like typing into the terminal on your computer, that wouldn't be something that we have to worry about for assignment 3. It's just GitHub functions that you were showing us, correct?
So yeah, so you can use those commands for assignment 3 to, like, if you want to do the assignment on your local machine and run everything on your local machine, then you could like, if you've used Python, like Jupyter notebooks before, you could like do everything on your own computer and then use those Git commands to submit the assignment. Alternatively, you can just do everything through Collaboratory for this assignment. For future assignments, as long as you do your coding in Collaboratory, which I am expecting for this course that at least most people will do, you can submit that aspect of your data stories through just through Collaboratory without doing anything in your local computer. But if you have like additional files, like a README file or like a data set that you want to add to your project, then you will typically have to do that through like using those commands.
Okay, thank you.
Sure. Is it clear to everyone how to submit your assignment? Should I go over that?
I would appreciate the clarification or the walkthrough.
Okay, sure. Okay. All right. So let's see. So here's our class GitHub page. And if you scroll down to module 3 and click on binary converter, that'll like get you to the assignment instructions and stuff like that. There's also this accept assignment link, and that will like create a version of your assignment that is just for you. You can go to. So if you type that address into your address bar, it'll make your own copy of the assignment. So you can't edit the class template version of the assignment, but the way you submit your assignment is to like use that link to create your own personal copy of it. And then, it'll be named binary converter and then your GitHub username. So Jeremy Manning for me, but you'll have your own username. And then the way you actually like see the code and the instructions, well, the instructions kind of are in the README file, but if you click the binary converter IPyNB for IPython notebook, it'll show you the notebook. Occasionally GitHub servers like don't render notebooks perfectly, and so it may be that you have to refresh the page, like if it doesn't come up. Sometimes that happens. I guess it's working now, but doesn't always. And then to like get an editable version, you click this open in Colab link. And depending on your particular setup, I don't know if you saw the like windows that popped up there. They might, I don't know if they were shared through Zoom, but there were some windows that popped up that like, said something about connecting with my GitHub account. So if you haven't connected Collaboratory with your GitHub account yet, you might have to like type your password and stuff like that. But that's a legit thing. Don't worry about Google stealing your GitHub password. They already know your GitHub password anyway, but yeah. Okay. And then what you want to do is like, edit stuff. So, let's say, this is my assignment. That's what I want to submit. Then to submit it, you go to File, save a copy in GitHub. Can you all see this window, this dialog box that popped up? Okay, great. It'll think for a bit. Okay, and I have a gazillion like organizations and projects, so you may not have this many, but what you want to do is scroll down to your assignment repository, which will be your GitHub username / oh no, let's see. Actually, I think it'll be under, where will it be? Oh yeah, context lab / binary converter, and then dash, and then your username. So this would be mine. Okay. And then just make sure the file path says like binary, whatever you want your notebook to be called, so that you can just leave the default. Sometimes, depending on how you open it, it'll add like copy or something like that, or copy. You can just delete that. And then you can, change your commit message to whatever you want, like my submission for assignment 3, whatever you want, or you can just leave the default message. Make sure the include a link to Collaboratory box is checked, and then press OK. To know it worked, it'll open up that notebook in GitHub, and then you should see any changes that you made reflected in that notebook. So in my case, all I've done is this is not how to actually do the assignment, but I've added this one string. Instead of having y be an empty string, I've made it yay, a very enthusiastic yay. So you want to make sure your actual code gets submitted. You'll know it's wrong if the thing that opens up is just the original assignment without any of your changes made. Okay. And then the other way to check is if you go back to your kind of home page for your assignment, which will be github.com/contextlab, which is like the global organization for this course. And then binary-converter- your GitHub username. That'll bring up this site for your assignment. you should see that like the binary converter notebook was changed more than 2 years ago, which is when the original assignment was made, but it should be changed like, whenever you submitted it. So in my case, 1 minute ago. If you don't get that sort of updated timestamp, then it hasn't worked. Kareem, did you have a question?
No, my bad.
Okay. All right. Any questions about that? Okay. Any other questions about assignment 3 or anything else? All right. Has anyone tried it out yet? Yes, Kareem. You have tried it out, or you have a question? Okay.
How do we submit something through GitHub, or do we just do it through Canvas?
that was the thing I just went through. So yeah, so open up your notebook in by clicking the link, open it in Collab, and then file, save a copy in GitHub. I'll share the recording so you can review the instructions. Then you go to Context Lab. You probably won't have as many repositories. Then binary converter dash your username, and then just OK. And make sure the file name is correct. That'll submit it through GitHub. Yeah, and that's how you submit this assignment. So when you submit the assignment, I get a little notification. There's like a GitHub Classroom thing, and I'll get a little notification when you submit. So, the way that I grade this is I have like some checks that run on the, each of your notebooks, and then, it'll make sure the code is running okay. But it'll run the checks on whoever's submitted the assignments. So if you don't submit your assignment, then, and like you submit the original unedited notebook as your submission, or like you don't have anything submitted, then it'll just run those checks on the, original assignment code, which will just crash. And then, the automatically assigned grade will be a 0. But like for any assignment, you can redo things, etc. So, don't panic if that happens. You can just either submit an updated assignment or get in touch with me and let me know, and then we'll get you on the right track. All right. Allison, yes. Is it just you in the classroom today, or? Oh.
No, Kareem's also here. It's just he's not in the video.
Oh, that's funny.
Yeah. So the first thing was he was worried that you may think he's not here, but he is here. So can he log off?
Oh, yeah. I don't grade based on attendance. So yeah,
okay. Well, just out of courtesy, he wanted you to know he was here.
Okay, I appreciate it. Thank you. I feel very respected. Thank you.
And then the second thing was, how do we get help on this assignment? If we particularly, I'm assuming it's still due Friday, right?
Well, a week from today.
So yep. The 4th, I think.
That sounds right. Let me see. Yes, that would be the 4th.
Okay. So if we're trying to work on it this weekend, or generally, how do we get help? Because there's not like a TA what?
Yeah, so you can. So first of all, now is an opportunity to ask questions. So we can talk through the assignment today. If you have questions that if you work on it over the weekend and things come up, you can also ask questions in class any day next week. You can also sign up for my office hours. And then you can also ask questions in Slack. and I'm pretty responsive on Slack. So, you know, if something comes up that you just want to like type out a question, then that's another way to reach me quickly.
And then what should be like in terms of like, you know, being respectful of your time? Like what on Slack, I guess, since like messaging, like what would be reasonable now? Like when are we allowed to message you, or like when can we expect you to respond?
So yeah, so you can message me anytime that's convenient for you.
Okay.
So in terms of when you can expect me to respond, I mean, during like normal business hours, I'm almost always on Slack. Often
Okay.
outside of business hours, I'm also on Slack, but you know, I'm not going to promise to like respond at 3 a.m., but sometimes I am on Slack at 3 a.m. So if you luck out, then that could, you know, I'll respond if I'm around and able. But yeah, but like, you know, if you message me and I'm not around or I don't have time, then like, I'm just not going to answer you, but I
Right.
won't be offended that you sent a message.
What do you consider business hours? Bless you.
I guess roughly 9 to 5, I would say.
Okay.
But I'm not like, I'm also not going to promise to be on Slack exactly during.
Oh, no. I know.
I
I'm
think it's just
asking.
like,
Everyone is different.
you know,
needs.
it's just a rough, you know, I guess I would say a very rough, you know, guideline. But yeah, in general, if it's like, you know, I don't know, I'm often like, I don't know, yeah, sometimes I have meetings in the morning, etc. I don't usually have meetings at night, but if you know, but sometimes I'm on Slack, like kind of doing work. So if yeah, if you can see when I'm online also, if you see the little green dot next to my name. So, but again, like if I'm in a meeting, even if I'm online, then I'm not going to necessarily respond right away, but I do tend to respond pretty quickly through Slack, just because I'm always using it, and I use it for my lab and for all my classes. So like I check it pretty regularly.
Well, I guess the reason I was asking is like I had a professor once who was like, I will not answer emails after 5 p.m. So that's why I was asking. So
yeah, that's yeah, I mean, that's fair. I guess my perspective is like, I mean, that's not my policy, but even if it was, I wouldn't be offended if you emailed me after 5 p.m. Like, you know, just get in touch whenever it works for you, and then I'll respond whenever it works for me. And hopefully it'll be soon after you write your message. But I mean,
okay.
I could imagine some situation where it wouldn't be instant, and then you know, we'll go from there. But so I guess I would say a common sense messaging protocol applies.
Okay, sounds good. Thank you.
Sure. Okay. Any other questions that people have about assignment 3 or any of the material thus far? Okay. I'm going to take that as a no. Kareem, by the way, if you do raise your hand, I can't see you. So, oh, sorry, Allison, yes. You might have to just get Allison to unmute if you wanted to jump in.
It's not that I'm just not great with using the mouse on here. My question was, do you have any updates on project 2 or assignment 2?
I haven't submitted your grades yet, but I can try to do that today.
Okay, cool.
So,
Thank you.
Sure. Okay, cool. So what I thought we could do for the rest of class, you know, if questions do come up, or if you want to, you know, help setting stuff up, that's fine too. So I'm happy to divert or get distracted or whatever. But I thought that we could go through some, you know, fancier ways of programming in Python that are kind of unique to Python and that you may not have encountered, particularly if you are used to other languages, but you may, depending on how you learned Python or who taught it to you, you may not have learned this either. One of the most kind of classic and uniquely Pythonic, it's called, ways of writing code is using a set of constructions that are called list comprehensions and generators and iterators. So I wanted to tell you about those. List comprehensions are like a special way of efficiently creating a list that's made up of transformed elements of another list or iterable object. And list comprehensions look kind of like a squashed version of a for loop. Okay, so let me make a little example. So yeah, so let's square the elements from 0 to 9 inclusive. Okay. Oh, it's gonna. Okay. There we go. Oh, Emily, yes.
Will you be able to share this with us at the end of class as well?
Sure, why don't I just share it now?
Oh, perfect. Thank you.
Okay. Where's the chat window? There it is. Okay. Okay, so, oops. Okay. So just to break this down, does everyone know what this syntax is? So it's like x to the power of 2. So we're creating the list y here, and each element of y is going to be based on an element of this kind of iterable object. So if you haven't seen what range does, well, range is actually a strange type of object. It's like a range object, but you can think of it kind of like a list of the numbers from 0 through 1 minus whatever you pass in. So 0 through 9. So range of 10 has 10 elements in it, starting from 0 and incrementing by 1. There are fancier, there are other ways of constructing ranges, like, if you wanted to count from, let's see, 2 to 19. Sorry, yes, Allison.
Kareem had a quick question. Do you want to ask your question?
Yeah.
Yes.
Is that Jupyter Notebooks or is that just a Google Collaborator thing?
Range or?
No, the whole like interface.
Oh, this is a Google Collaboratory notebook, but you can also run this stuff in a Jupyter notebook. The only downside to running in a Jupyter notebook on your local machine is that you may not have all the same packages installed.
Okay.
But that's,
I guess going off that
fine with
question,
me.
how do you, is it kind of like making a Google Doc on Google Drive? Like, how do you make a new file?
Yeah, so you just go to collab.research.com.
Okay.
You have to spell it right though. It's probably collab.research.google.com actually, I'm guessing. And then that'll pull up this thing, then you press new notebook.
Okay. And then so every, like, I guess a Google Doc is considered like a new, like every file is called a notebook, if you will.
Yes.
Okay.
Yeah, so if you watch yesterday or Wednesday's recording, I went through like, yeah, so the class was kind of split off into multiple streams, but if you watch the recorded part of yesterday, I talk about like, making a new notebook and what it means and stuff like that. So that might be useful for people.
This
But
from Wednesday, or you talking about something
this
else?
is from Wednesday. Yep, our last class.
Okay, thanks.
Sure. Just the other point about range that I wanted to point out is you don't have to increment by one. So the first, if you pass in two numbers, it goes the starting point, one more than the stopping point, and then you can also pass in like an incrementer. So if I wanted to count by threes, then I could do that. And then like one more than the stopping point means if I added the incrementer to the last element, then I stop if that value is greater than or equal to the endpoint. So notice this one stops at 17, even though, which is like more than one more, or sorry, more than one less than 20. So, does that make sense? And I think you can do decimals, but we could check that. No, you can't. There's another way to do decimals using another library called NumPy, which we'll learn about next week. But yeah, there we go. So, but don't worry about that. Okay. Anyways, so you get a list, you can think of this range of 10 as a list of 10 things, the integers 0 through 9 inclusive. Okay. Now, if I just said like x for x in range of 10, that'll just give me each element of this kind of list like thing. Sorry, got something in my eye here. Okay. And the like 4x in range of 10 piece gives each element of this iterable, like each value in turn of the iterable object, the name x, so that you can refer to each element in turn. So iterables in the general case are kind of list-like objects in that you can loop through them element by element. That's what an iterable means. And then the x squared piece says the way that you assign each element in turn of this list to the corresponding element of y is you use whatever you pass in as this formula. So you take the value of x and you square it, and that becomes that value of y. And then the square brackets on either side tell Python to organize the result into a list. And then, the full expression on the right evaluates to an object of type list, and then that gets assigned to the variable y. Allison, did you have a question or just kind of pointing at the
Yeah, I was
screen
asking
there?
for Ian. I guess two things. One, for the NumPy part in the beginning, is that just to kind of like import all the different functions you may need later? If you will.
Why did I have NumPy in there?
NumPy, sorry, I butchered the name. Yeah,
Yeah, we'll talk about that later, but don't worry about NumPy. We'll talk about that next week.
Okay, and then my second question was, I guess, why are you like, assigning like, I feel like, I guess you're doing it like in like one thing in two steps, like, because you have like, I guess the list, which is the brackets, and then you have like a function, or like, then you're like actually doing something within the list. So can you do that all in one step? You don't have to like first make a blank list and then do like, I guess, I don't know if function's the right word, but like then have the x like to the root 2 for x in range 10. Like, I guess you can do it all in one step.
Well, so yeah, so we could think about what's the like loop way to write this. So we could say start y as an empty list and then say for like x in range 10, y dot append x squared, something like that.
So is what you did just basically a simplified way of the same exact thing?
Yeah, so you can think of it as like a flattened version of a for loop. It's even
Okay.
got the for keyword in it. And for each element of this kind of iterable object is given the name x, and then this expression out front tells you like what to do with that. So usually it's like transforming that value in some way when you're constructing the full list at the end.
Okay. Gotcha. And then also, is it possible, I know this is kind of a pain, but just to keep up all the code you have and just like keep going down the list, because that way we have access to everything you type, even if it's not relevant as you continue on.
Yeah, that's fine. Sure.
Thanks.
You can also have, like, if you click the all changes, it has the full
We can go
history.
back. Okay.
Yeah.
And and then you said you'd be sharing this with us, so then that works too.
Yep. The link's already in the Zoom chat if you want to follow along now.
Thanks.
Yeah. So these are just like any other Google Doc. It's like another benefit to using Collaboratory. It's saved in your Google Drive and it's got like the full version history. And if multiple people work on it, it'll track like who does what. So it's pretty nice. Okay. Okay. You can also incorporate conditional statements into list comprehensions. So we could make a new list that's like squares all the elements of 0 through 9, but only if the numbers are even. And to do that, we add a little if statement at the end, which is also it's like a strange version of an if statement. So does anyone remember what this % sign is? What operator that is? Yeah, Kia.
It finds like the remainder.
Yeah, so it's like 2 goes into X however many times, and the remainder is, and then that's what this whole thing returns. So just to like make that concrete, 3 remainder 2, does anyone know what that, or sorry, 3 mod 2 is what it's called. Does anyone know what that would be?
1.
1, yep. And then 4 remainder 2 is going to be what? Nope, close, 0, yeah. The other option. Yeah. So if this expression evaluates to 0, then this whole thing is going to be true. And so we're going to take all the elements X in this kind of list-like thing, but only if this expression is true. So only the even elements. And then for those even elements, we're going to square them. And that's how we're going to construct the list Z. Okay, so let's see what that looks like. Okay, so we took the integers 0 through 9 inclusive, threw out all the odd ones, kept all the even ones, and then squared them. So 0, 2, 4, etc. Yes, Allison.
So you kind of said that like the way you're writing it, I guess, is like an I guess abbreviated version of the same thing as if you did like a for and if. Is there a way like clicking on it for it to expand out to that, or you just have to know that it's expands?
No, you just have to do it. So you could say if x mod 2 is 0, let me do this. So that would be the equivalent.
Yeah, I mean, I guess I'm just not that familiar that it's cool though. So I guess what are the conventions for that, or how many like for if statements can you put within a bracket?
Yeah, so let's let's see how fancy we can get. So you can like assign, you can also incorporate like if and else. That has a slightly different syntax. So let's maybe call this Z1. And then let's call this Z2. So we'll say we're going to square let's square the even numbers and do nothing with the odd numbers. So we'll say, let's give Z2 the value x squared if x is even, or if the remainder when x is divided by 2 is 0. Otherwise, we're just going to give it the value x, and then 4x in range of 10. So we've got 0 squared is 0, 1 not squared, although we can't really tell, 2 is squared, 3 is not squared, 4 is squared, 5 is not squared, 6 is squared, 7 is not squared, etc. Yeah. There is no, oh, Kareem, did you have a, sorry, I saw a little
Sorry,
hand
I realized
kind of in the back there. Yeah.
So I rewrote the same line of code as you, but it seems as though when you write an if statement, it kind of wants me to put a parenthesis or something before the else statement. I don't know how to fix that, or like whether it's like a problem. Like, am I supposed to do?
Do you want to paste into the chat, or could you share what your,
Do you want to send it
or
in
maybe,
Slack?
Yeah.
okay, I could pull that up. Yeah, sure. So you want to paste it in the Slack?
Yeah.
Sure. Okay, programming issues. Okay, so okay, so let's see. So oops. Okay, so the issue is that if you include if you include an else in your if else block, it's got to go in the beginning. So and then the other issue here is like you included the 4x in range 10 twice. So this will work, I think. Yeah.
Got it.
Wait, can you put his code into, so we can see the difference?
So I had two.
Yeah, well, this will just crash, but
Well, still that way we can see. And then what's the correct code?
this one.
Could you put them next to each other or write like correct or something, just so we know?
Sure.
Thank you.
I mean, I feel like I could say like wrong.
You can get rid of his
There we
name.
go.
I mean, it
Yeah.
doesn't really matter. It's more just helpful to see it both ways.
I think the dog.
Mystery student example.
Yeah, I'd
There we
say
go.
honestly, it was helpful. We all learn from mistakes, so I appreciate it.
Yeah. Okay, this won't run, by the way, because it'll crash before it gets to the correct version. But if you're, yeah, I can leave it.
Maybe you can comment it out so it'll still run.
Okay.
Thank you.
So yeah, so here's how you include if and else. So it's also kind of a weird syntax. There's no specific way to include an elif, like an else if, like the Python version of that, into list comprehensions, but you can get the same functionality by kind of nesting else and if statements. So let me just make a, let's see, so okay, let's say if x is divisible by 3, then we'll just keep x, else we'll square it if it's divisible by 2, so if it's even. And then otherwise we'll cube it. Yeah, there we go. Oops, I'll print it out too. Yeah, so we've got, well, 0 looks the same no matter what. But the first thing that gets caught is if the remainder when x is divided by 3 is 0, then we just get x. So this is, this is the version of 0 that's being printed out, just regular 0. 1 does not go into, or yeah, sorry, 1 also goes into 3 evenly. So that's just an unmodified version of that. 8 divided by 3 has a remainder of 2. So this statement is false when x is, I'm sorry, x is 2 at this point. 2 divided by 3 does not go in evenly, so this statement is false. X is evenly divisible by 2, so we're gonna, let's see. Oh, I forgot this. Okay. X is, I was, yeah, confused there. Yeah, if x is even, we're gonna square it. And then otherwise, if it's not divisible by 2 or 3, then we're gonna raise it to the 3rd power. So 0 is divisible by 3, so it gets unmodified. 1 is cubed, 2 is squared, 3 goes into 3 evenly, so it just gets its original value. 4 is evenly divisible by 2, so it is squared. 5 is neither divisible by 3 or by 2, so it's going to be cubed, and so on. Let's see. So that's kind of an example of how, and you can have like arbitrarily many conditions and whatnot. So it can get quite complicated. Let's see. You can also, another useful thing is the enumerate operator, which you can use to, well, I'll show you what it does. So let's say we have a list for character in A, B, C, D, E, F, G, print C. So this will just, oops. That's the Python 2 syntax. So this will just print out each element of this string. But we can also print out the positions of each element using enumerate. So enumerate returns like a list of, they're called tuples. Let's see. Of like, which are like little kind of mini lists, where the first element is the position and the second element is the corresponding value at that position. So when you loop over it, this syntax unpacks each tuple and assigns the first element to the value or to the variable I, and the second value in the tuple to the variable C. So, the first time this goes through, I gets a value of 0 and C gets a value A, and then it prints out the message. So sometimes this is useful for when you're like trying to make a fancy list comprehension. Okay, remembered my alphabet there. And then you could say, let's only take every like third letter. Or sorry, well, we could take every third letter. Why not? Okay, so we're going to get, so I is now the position. If 3 divides evenly into the position, then we're going to keep that letter. Otherwise, we discard it. Or we could like discard every third letter. There we go. Yeah. Let's see. Oh, zip is another useful thing. Let's see. Okay, so we'll make okay. Okay, so we're going to make 2 lists or range objects, but you can think of them like lists. One's going to be the numbers 0 through 9, and then the other is going to be 9 through 0. We can combine them using zip. So in a for loop, it would look like this. So it's like you're taking, for 2 lists of the same length, you're taking the corresponding elements of both of them. And then the first list's value gets assigned to X, the second list's value at that position gets assigned to Y. Yes, Alex.
There, the F is the enumerate function, or
F here?
yeah, what's the F doing again?
Oh, F is just a format string. So
Okay.
This is a nice one. So let's say, so X has the value 9. So the string X is equal to, and then if you like put it in curly braces, then
Okay.
Python will replace the curly braced expression
Gotcha.
with whatever it evaluates to in the middle. So it's a
Okay.
convenient way of doing that. And you can have any Python expression in here.
Cool. Sweet. Thank you.
Yeah. It gets confusing if the Python expression doesn't return a value. So like this would just, yeah, so the print function returns none and also displays the number 9, or whatever the value is on the screen. So when print x is called, it executes its function, which is to print out the value 9. But then the whole expression evaluates to none because print doesn't return anything. And so this expression here gets turned into the string none. And then the whole thing gets printed out as x is equal to none. Anyways, weird. I should have probably chosen a value other than 9 to distinguish from none, but oh well. Okay, so that's how zip works. You can also zip as many things as you want. So, you know, you could have, if you had a third list C, you know, that's totally fine too. Okay. And let's see the kind of list comprehension way of dealing with zipping. So we could say, let's take the difference between those two elements. And make a new list. That's just the difference of these two lists at each corresponding position. So we're taking like 0 minus 9 is -9, 1 minus 8 is -7, and so on. All the way up to 9 minus 0 is 9. So list comprehensions are a little tricky to get used to, but they're a really nice way of writing like super compact and readable code, especially once you get used to them, or possibly only once you get used to them, but it does make things more readable once you get used to them. So it's worth practicing. There can also sometimes be like a minor speed up when you're replacing a for loop with a list comprehension due to the way that Python like compiles the statement into machine code at runtime. But often that speed up is quite minimal, and sometimes it actually goes in the wrong direction. So like the main benefit is that your code becomes easier to read once you're used to working with list comprehensions. Okay. Any questions on list comprehensions? Okay. Yeah, so you know, if you want to, you don't have to use list comprehensions in this course. It's kind of just a nice Python thing. If you want to dig more into these ideas, Python also has a similar syntax for creating dictionaries and also sets that are called dictionary comprehensions and set comprehensions, respectively. Since they're pretty similar to list comprehensions, I don't have to take up class time to go over them. Although, if you're curious, I'm happy to answer questions about them. But tutorials are also kind of readily available on Google if you wanted to look for those. Do you want to see like one example of a dictionary comprehension or a set comprehension, or are you all bored? You want to, oh, thumbs up, that means yes, okay, sure. So let's see, we could call this squares. Let's make a dictionary whose keys are like the integers 1 through 10, or sorry, well, sure, we could make it 1 through 10, and whose entries are the squares of those values. So the way that we work is you do what the key is, and then what the value is. So key : value, and then the rest just looks like a list comprehension. So for I in range 111. And then the other difference from list comprehensions is I've used these curly braces. Okay. So here's what it looks like if I print it out. And then I can like squares of, let's say 3. We'll return that. Okay. And then, anything can be a key. An integer can be a key, or a string can be a key. So if I wanted to turn these keys into strings, now it works slightly differently. So squares 2 of 3 is now, the key is not going to be found, so I've got an error. But squares 2 of the string 3 is now going to give me none. Weird. Okay. And then the last thing is like a set. So a set is it's kind of like a list, but it's unordered, and each element can only appear once. So you can have a list, 1, 2, 3, 4, 5, 4, 3, 2, 1. Okay, that's totally fine. Python is happy with that. But a set is kind of like, you make a set sort of like a dictionary, but you just add curly braces instead of square brackets. And in a set, each element can only appear once. So if there are repeated elements, they just get ignored. And then the ordering is also arbitrary. So, there's no first element of a set. But you can make you can write a set comprehension by just replacing the curly braces, square brackets with curly braces in a list comprehension. So you could just do for I in this list, and that will make a set X.
Could you comment in here that this is a set and everything can just appear once? Thank you. Thank you.
Sure. Also, the other thing you can do to remind yourself if you're going through this is looking at the type of the data.
Okay.
And also type of squares is a dictionary. And then we made it. I see a list comprehension where we made Z, and that's of type list. Okay. Let's see. We only have 5 minutes left. The other kind of interesting Python thing is called a decorator. Maybe I'll just show you a quick example of it. We're not going to have time today to dig into it, but it's another kind of powerful thing. It's so if you think about a decoration in your home, you can take your kind of uninteresting space and spruce it up a little bit and add functionality. So that's where the name comes from. A decorator in Python kind of does the same thing. It adds functionality and maybe appeal to your functions, and also you can apply them to classes as well. Let's see, let me just write one out. Yeah, function or decorators are a bit strange. So they take as their input a function, and they return another function. Let me okay. Okay. And then we can make a function. Oops. Okay. So if I just call this function normally, prints out, oops, I have to actually call it. It prints, it executes the function. But I can also wrap this in okay, so this will return a function, but I could call that function. And now what it's going to do is so the decorator takes in the function I pass in and returns a new function that first prints out this line, then runs that function, then prints out this line. So the decorator function takes in this function I passed in and it returns another function. And then the parentheses run that function. And that function, because of how I've written the decorator, is going to end up running this first function. It's kind of weird. There's a kind of special syntax for doing this efficiently, which is you can also just use the @ symbol and then my decorator. And now when I call say we, it will use the wrapped version of that function as opposed to the original function. Yes, Alex.
Whoa, that's weird, the @ symbol. But before that, I was thinking, why do you need to have the wrapper function as a thing? Could you not just have my decorator that takes in a function and then prints something, function, and then prints something?
Oh yeah, sure. So you could have like another function of func, and then let's copy this. Yeah, so this would be totally valid. And then you could just, well, okay. Okay, there we go. Yeah, so that's totally fine. This is going to return, like nothing is returned here. So there's no function here.
I see.
But yeah, the same thing got executed. But when we use the decorator syntax, now this whole function does something maybe different or supplemental to what it did before.
Okay, gotcha. Cool.
Yeah, so it actually gives you a totally new, so it's like a function still, but you can call it, and you can call it just like you did before, but I only specified here's what to do in the function, print out this one thing, and the decorator modified the functionality, and it can happen both before and after the thing in this function runs, which is kind of interesting. You could also like, what if I wanted to run it twice? So now now I just call this function once and it runs my original function twice, doing, potentially interesting things in between each call. So yeah, so if people are interested in using decorators, I'm happy. There are like other fancy things you can do with decorators that are kind of neat. One of the places that I really like to use decorators in my own code is like, if you write a function that we'll get more into like data types and data science libraries next week, but if you write a function that like, wants to deal with a particular data format, but you're not sure that the data you pass into that function is in that format, you can have a decorator that handles all the like annoying data wrangling stuff and kind of converts a string to an integer and like a none type object to a 0, whatever you want, and then passes that stuff to your original function. And then you don't have to handle those things in your analysis function. And if you have like 2 analysis functions, you don't have to rewrite that annoying stuff. You can just have one decorator that kind of, takes care of it every time. So we'll, particularly when we get into like data cleaning, we'll see how that's, useful. But if you haven't dealt with data yet, it might be too abstract at this point. All right, so that takes us to the end of today's class. So thank you for going on that Python journey with me. And next week, we are going to dig into some like kind of more data science-y libraries. And libraries, you'll see, kind of extend the functionality of Python. So we'll talk about that stuff. In case this is your question, next week is also going to be remote. Was that your question? I know. Yes. Got to get the numbers down on campus. Yeah, I know. I don't like it either. Yep. So was that your question? Yes. Okay. So I will see you on Zoom next week, and we'll dig into Python libraries. You can get a little preview if you want to go through the Module 3 material, and I've also posted my slides for Monday so that you can take a look at those if you want. All right. Yes, Allison.
So I guess I feel like today we went through, we were kind of using GitHub, but we were still going through Python. So would you say to go through all the GitHub videos still, or go through the Python videos? Because I went through some of the GitHub ones, but I'm still not totally seeing how it correlates to what we're doing now. Or is it relevant for the project? So we should go through it.
So if you haven't used GitHub before, you may find it useful to go through those videos and understand like why you're submitting your assignment through GitHub, what that means and all that. You're not going to use all of the GitHub commands that are covered by those videos for assignment 3. But as we go on in the course, you will.
Oh, okay.
So, the way I think about it is it's like, this week is kind of a soft introduction to like, okay, if you haven't programmed before, here's what programming is, and here's what Python is, and here's how you like, the thing you do on your computer to run code and all that. And then also here's like what GitHub is, and here's the thing you do to submit this first assignment. But you don't have to dive in, fully to GitHub quite yet. You just kind of use it in the easy way the first time. As we move on in the course, like for assignment 4, you might have to rely on those more complicated commands. So it's worth kind of getting familiar with them, or at least getting exposed to them, while we're in the kind of learning module, and then you'll use various pieces as we go on in the course.
Okay, so you're saying do the GitHub stuff, look at the assignment 3, and there was one other thing you said we should do.
Well, I've posted the material in module 3 because I think it's useful. But
yeah, so look at module 3
you
and then assignment 3. Is there a third thing, or just those 2 for now?
Nope, just looking through the module 3 material is great. Next week, I'm hoping we'll finish module 3, and then we'll get to, then we'll have all our data science tools that we need, and then we can start digging into, playing around with actual data sets, which will be exciting. And we'll also talk about data visualization in Python next week. So that's one of the libraries that we'll play around with.
Well, thanks so much, and have a nice weekend.
All right. Bye, everyone. Have a great